So it's time for another talk that I've shortened the name from the program towards Emergent2 kernel, which should maybe give you an idea what this is about. I will also introduce myself a bit. I don't have a slide for that. As you can see on my t-shirt, I am also one of those guys who work at Gentoo and at SUSE at the same time. And I use Gentoo since 2006 and also became a developer that year. I focused on Java packages before, but since I joined SUSE, I work on the kernel there for some months, for a year and some months. So it was natural for me to also join the kernel team at Gentoo because I'm not really that interested in Java anymore, and the guys in the kernel team needed some new help. So in the kernel team at Gentoo, we deal with the Gentoo sources, packages, and other stuff, the other flavors of kernel, and this talk is about something that's not that doesn't exist yet as a code. You could guess it from the word towards. If you are experienced with reading academic papers, if there is a towards in the name, it means it's basically vaporware. But this is just because I got these ideas only some short time ago, and there wasn't too much time to actually implement them, at least as a prototype, which would be nice. But I was thinking a lot about this during public transport travels and so on, and I would like to present it to you because we have some developers here as well, and maybe you will have some ideas where to improve it or point out what I missed before we actually start the coding, which is also a good way to avoid writing something that won't work in the end. So I should probably ask you how many of you have built a kernel yourself? Well, that's great. That means you will be able to understand easily everything what I'm going to say. So, and I guess many of you are also Gentoo users. If not, then you already had some talks, heard some talks that should give you the idea. So what's the current state in Gentoo with respect to the kernels? There are packages which provide the kernels, and they are very different from the other Gentoo packages, the ebuilds. Usually ebuilds, build the thing and install it on your system, and you can start using it. But the kernel packages are, it's even in the name, it's something dash sources, Gentoo sources, vanilla sources, Git sources, or the hardened ones that Tomáš was proposing to use. And this is sources, and it just unpacks the sources into your final file system, and then you have to configure, build, and install the kernel manually. Or there's a tool called GenKernel which can help you. I must admit I've never used it myself yet, so I don't really know how well it works. I know there are many bugs open against it, so maybe it doesn't work as well. And I think this is actually a problem, because this is not the Gentoo way. Or maybe it is Gentoo way, depending on how you look at it. Because if you install Gentoo, if you are installing Gentoo, you are used to run many commands manually, going through the Gentoo installation handbook. And as Tomáš said, it can take you varying amounts of time, and there's lots of space for making some user error. And installing a kernel is really like continuing with this Gentoo installation process. But if you are a Gentoo user, you are used to that after you went through this installation process, you have the emerge tool, and that will build everything for you. You don't have to do lots of manual things anymore, especially if you just want to update. But in kernel, every update means that, again, you get new set of sources and you have to compile them manually. So why should the kernel be different from all the other packages that Gentoo can build for you sort of automatically? So it's just to expand on why I think this is bad. I said there's a lot of manual work involved, you can easily make mistakes, then you lose all of the nice support that emerge has, that Tomáš was talking about, the distcc and ccache. You can use it for the kernel, but you would have to set it up manually outside of the emerge environment. You don't get binary packages support. I guess these weren't mentioned yet today. Binary packages are useful if you have like a computer lab at university with many computers that look the same. So you want to compile the stuff just once and then distribute the binaries. So you are sort of using Gentoo a bit like a binary distro, but still you compile it once from source and then distribute it. And with kernel, you would have to set up some manual process for this. But emerge would be able to do it for you just by putting all the binary packages at one place, and that's accessible from all the machines, and they can just install them. Then there's a problem that if you are installing sources for the kernel, you are potentially wasting a lot of space, because once you build the kernel and install the image and the modules and init-rd, you don't actually need to have most of the sources just sitting on your disk anymore. Even if you have some other packages in Gentoo, like NVIDIA drivers and others, that need to have access to the sources so they can build, they actually don't need all of them. They need just some headers and the configuration and some precompiled headers and stuff, and not the sources of all the other drivers. That's not important. And so, for example, on the latest stable kernel, you can measure that 600 megabytes are occupied by the sources. Then which can be quite a lot. And if you are building the kernel and don't just take care to remove the objects afterwards, then on my machine it was additional hundreds of megabytes, so in total 1 gigabyte per kernel. Yes, you can clean the objects. Emerge won't do that for you, because the objects were not installed as part of the sources, so it won't be touching them. You would have to delete them manually. And if you don't take this care, then you can end up like me, because 1 week ago I realized that on my desktop I have 16 gigabytes of maybe 20 kernel versions around that I neglected to clean out. So then you can start running out of space. Then there's the problem of packages that depend on something in the kernel configuration, like the NVIDIA drivers and others. There's a support for checking if the configuration is matching what they need, and if not, then the build fails or the package doesn't work. And it would be nice if these requirements of other packages could be incorporated into the configuration for the kernel automatically. So that's another goal. But back to why is the kernel done so manually? Why it's not done the Gen 2 way? Because, building kernel, it's simple. It's just a make command. Installation, that can be a bit more tricky than, installing other packages, because you have to create often the init.rd, you have to configure bootloader. But let's assume that this is solvable. If the kernel doesn't work, that it can be fixed. So that's really, I think, not the largest obstacle for doing this automatically from eBuild. So obviously, you already said that you are experienced with building the kernel, so you know that the largest issue here is the configuration. So this is the main focus of this talk. So in Gen 2, for configuring features of packages, we have useflex. So maybe we could use useflex for the kernel. Probably not, because, for example, the configuration file for latest OpenSUSE kernel has over 6,000, almost 600 lines that tell you, I want this feature, I don't want this feature. And if we are to convert it to useflex, then it would be unusable, and we would lose all the support that the kernel configuration has for managing this. So that's really not the way. The problem is that all of these configuration options can be very specific to what the user wants and what kind of hardware he has on his system, if he wants to tune something or debug. And if you forget some important driver, then your system won't boot. So that's, I guess, why it's hard to do this automatically. But we can observe that the binary distros actually manage this somehow, because they do distribute binary kernels. So that's just one or maybe few configurations that are then used by everyone, basically. So apparently it's possible to create some configuration that's enough for many people. And actually Tomáš Chvátal approached me a month ago and said, I'm really tired of this kernel building on Gen 2. I just installed the OpenSUSE kernel from the RPM. So can't we just package the OpenSUSE kernel as a binary in Gen 2 for people who are too lazy like me? And yeah, maybe we could, but that wouldn't be Gen 2, right? But they have this nice config that they've already tuned I shouldn't say they because I'm now part of the team as well, so I won't be stealing from somebody else, I will be stealing from myself. So let's just get the config and maybe tune a thing or two so it works on Gentoo. We don't need the systemd crap usually. So the first step, I think, towards the simple kernel installation in Gentoo would be to maintain such generic configuration by the kernel team. And yeah, we can start with one of those that was proven already in other distros. Hopefully it will be compatible with all the dependencies that are needed by the packages like NVIDIA drivers and others. If not, then it depends on how important such packages are. Yeah, that wouldn't be the complete solution. So the eBuild would just take this config that would be distributed together with our patches, the Gen patches, and then it should be quite easy to just compile and install it in the eBuild. And you get still the Gentoo advantages compared to distributing just a binary kernel, so you can choose the GCC version. We could provide at least some variants of the config. For example, if it should be low latency on your desktop or high throughput on the server, and this could be selected by the useflex, and it would be all fine. One thing the racers probably won't like is that the CFlex are not, that you set in your makeconf are not directly propagated into the kernel build. And I didn't think we wouldn't want to override this, because then if upstream finds out a bug report from Gentoo, they would be, oh, those crazy guys said some crazy CFlex, I'm not touching it. We really shouldn't encourage that. So the configuration of the kernel lets you set some basic classes of processor types, and according that they set CFlex themselves, but rather conservatively. Maybe we could, check the CFlex of the user and map them back to the kernel options. So it would be at least a subset of what the user can set in the CFlex. So this would be the first idea, how to create a binary kernel package the Gentoo way with quite a minimal effort. And it turns out that this has been already done before. You heard about some of the Gentoo derivative distributions in the Tomáš's first talk. So there's Fun2, maintained by Daniel Robbins, and they have a use flag called binary for some of the kernel sources they provide. Yeah, basically these Debian sources, so they're also stealing from other distros. And they also have some fork of Gen kernel that could be maybe used. And if you have this use binary, then it doesn't install just the sources, but also builds the kernel and installs it for you. Calculate Linux has another flag called VM Linux for the calculate sources package, and it's very similar. They just use some different tool called CL kernel if you want to do this manually. Then there are some forum posts asking about this. a bug report. There was even a GLEP in 2004 that proposed the kernel binary building, but I guess it never took off because probably the guys involved didn't have time for that. So it was a proposal that was never accepted or implemented. So how we should do it? We could take the way of adding a binary use flag to Gentoo sources like Fun2 and Calculate Linux, but I don't think it's the right way because then you still end up installing those sources next to the binary, and as I said, they are mostly not needed. What you need is some subset, like the headers, that you have to install so other out of the three modules can build. And this would be something like the kernel devel packages that the binary distros have. And you can see that's a lot smaller, just 85 megabytes. In Gentoo, we don't provide these devel packages manually or as an extra package. It would be installed always together. So if you are not installing all the sources, then based on some use flag, then calling the package Gentoo sources is sort of misleading. So I think it should be a different package that wouldn't install the full sources, but just the reduced set and the build, the image and the modules. And it would be also simpler for maintenance because these two the sources and binaries wouldn't have to be always bumped and stabilized at the same time. So I have not settled on any name yet. You can give me your ideas. So let's call it Gentoo kernel for now. And it would really build the usual way in your Portage TMP dir, install the VM Linux outside of the live system, and then the Portage can manage it as any other package. The dist files would be same because it's mostly the same sources, plus there will be the generic Gentoo configuration maintained by the journal team. This would need to be updated by us, by each version bump, and as I said, there can be more variants based on use flags. And the sources it would install would be just the subset for building other packages, and it should be possible to get all the nice Gentoo support for bin packages and Ccache and CC this way, because it would be basically a compilation in Portage like any other. The installation of initial RAM disk or configuring the bootloader would have to be done in special phases that work on the live file system, like the package postinst phase. Maybe we will be able to use gen kernel, maybe not, we'll see. And yeah, after you uninstall the package, the post removal phase can clean up everything it is done on the live system when installing. So it should be really good. So what's the advantages and disadvantages of this? Big advantage, it should be very simple for the user. You wouldn't have to do anything special, just keep using emerge like for any other packages. if there was a bug report for the kernel, we would know that he used this generic Gentoo config, and it's not a configuration error on user's part, so that will be also easier to reproduce bugs or report them upstream. But yeah, it would be more work for the kernel team. But I don't think bumping the configuration for new kernel version, I don't think it would be too hard, so it shouldn't be that much work. The disadvantage, of course, for many users, this would be not custom enough because they want to configure the kernel themselves, and this would install just a generic configuration. And then there's unfortunately lots of practical disadvantages. If you're doing a generic configuration for everyone, you need to basically include all of the drivers that some user can have on their machine, because it's not customized, so you have to really cater to everybody, and that means the configuration is quite large, and that, for example, means it takes long to build. Not as long as LibreOffice, but still on this laptop it was 40 minutes, and that's with SSD and that stored the sources, and RAM disk to store the object files, compared to 6.5 minutes when I use my custom config that uses just the modules that are needed on the laptop. The Fun2 page wiki says that for the Debian sources it can take 1 hour on i7, so that's even more than 40 minutes on this i5. So I guess the config is maybe even larger, or they are using some older GCC, I don't know. Another disadvantage of the large configuration is that the modules that you build will also occupy your disk space. So again, with the OpenSUSE config, which is generic, that I've tested, you get 5 megabytes, the kernel binary, that's nice, but 170 megabytes of modules. With my own config, the binary is larger because I compile some drivers built in, because I don't bother with initial RAM disk, and the modules are just less than 8 megabytes, so that's quite a difference. A surprise comes if you use the OpenSUSE config as it is, because it has enabled the creation of debug info, and then the modules take 2.4 gigabytes of space, which on binary distros is handled by storing them in a separate package, debug info, that you only install when you need it. On Gentoo, that means you probably wouldn't want to build debug info unless you really need to debug something, so that's really an opportunity for some use flag. But if you need to debug something, then you have to prepare enough space using this approach. Also, the build space that's occupied during the build will be quite large. 1.4 gigabytes without debug info, 9 gigabytes with debug info. Again, the custom config is much less. Fun2 page says that you need 14 gigabytes temporarily to build the Debian sources, and that actually you can get to these numbers if you add that it probably means they built with debug info, so they have something like 9 gigabytes of temporary objects, then 2.4 gigabytes of the modules that are first installed inside the TMP there and later transferred, so that can easily get you to 14 gigabytes. And unless you have lots of RAM, that means you wouldn't need to, you wouldn't be able to build this on RAMFS. Then some disadvantage or not, depending on the point of view. Everything needs to be modules. You cannot compile the drivers built in if there are so many of them. The binary would be too large. That means you would also always need to use init.rd. I guess it's not a big trouble. I personally never needed it, but I guess it works. But there's still some opportunity for something to go wrong during the creation of the init.rd. So yeah, we would have to live with that. And there's the possibility that the generic config cannot really satisfy the needs of all the e-builds that are building against the sources, the drivers that are external, and because they might request conflicting features. So the question is, can we deal with these disadvantages and still keep the things relatively simple for the user? So that would be the step 2 after the generic Gen2 config, would be to add some way to let the user customize it to some extent, but still keep it working via Emerge, so he doesn't have to work with this config manually and build and install manually. So basically that's looking for a way so that users can state some requirements. The e-builds building against kernel can state some requirements, and the whole thing shouldn't break on a version bump when some of the configuration options in the kernel change. So the very first idea that comes to mind, okay, let the user create some config, maybe starting with the generic Gen2 one and just disabling some drivers and setting his CPU type and some features he wants or doesn't want, and then use this in the e-build instead of the Gen2 config. And the question is, what can break when the user config was created for version 3.16 and now we want to use it on kernel 3.17. So this is a list of what I think can happen. It may be not complete, so if you know more problems that can occur, then feel free to tell me. So the first thing is that in each new kernel you get new drivers, new features, and that means new configuration options. And if you compile the kernel, you know there's a make old config command that will ask you about these new features that you didn't have configured yet. And that's interactive, and we really don't want to be interactive in the Emerge process. So that's very common change that happens on a bump. Then some configuration options might disappear, and that means the old config won't be able to enable them anymore. A special case I think can happen is that some options are renamed or completely drivers are replaced. I know that there was one driver for HP storage arrays that was deprecated and replaced with another one, and we would have to deal with this something somehow. Sometimes it happens that several options are hidden behind some new umbrella options that I don't know recall any real example right now, but you can imagine that some new drivers start to appear for some class of devices, and if there are too many of the drivers, then upstream kernel decides to add some option that if you don't enable, you don't have to answer the configuration about each of the drivers separately. You see that in an example, so that will be clearer. Sometimes default values change. For example, the memory allocator for SLAP memory allocator implementation was some time ago switched from SLAP to SLAP. SLAP to SLAP. So what to do? Should we get the new default, or should we let the old users default override the new one? And the dependencies can change, so options can become in conflict with other options, and that can be also a problem. So the solution to this, on the first side, I imagine that the user would say which configuration options he or she cares about having either enabled or disabled or as a module. So they can start with the generic config and disable some of the drivers they don't want, and then the configuration will be stored somewhere in etc, and the kernel ebuild would read it. And to deal with the updates, the options that were not specified by user would be taken from the generic Gentoo config, which would still be provided. From now on, I will call that a default. That means the generic Gentoo config. And because it's always updated by the kernel team to the latest version, it shouldn't ask you questions about new drivers, because it was already decided when creating the Gentoo config. But this might look easy, but there are lots of practical issues there. So how do you distinguish options that were specified by the users if he just happened to agree with some of the default value? And when the default changes in a new version, then the old value in the user config would override that, because he's already seen the value, but maybe he didn't set it explicitly, just agreed with the defaults. So it has to be done in a better way. And so let's look at it from the practical point of view. So how, just to get the idea how the configuration works in kernel, there are so-called kconfig files distributed around the source tree that configure stuff that belongs to the part of the subtree. So here are three options: USB storage, storage debug, and storage realtek. And the first one is about the whole USB storage subsystem. The second adds some debugging. And the third is a special case for some storage devices from Realtek. And you can see that the second and third one depend on the first one. And when you create a configuration, you can get a result like this. That means the USB storage subsystem as a whole would be built as module. the debug would be enabled, and since you didn't want to Realtek support, then it adds a line that looks like this. It's not config USB storage equals n, but just a comment for some reason. So if we were to do what I proposed, you could get a user configuration based on some kernel 3.12, where the user said that he doesn't want the Realtek driver. Then the generic Gentoo config based on 3.13, because it's a kernel update, looks a bit differently. The Realtek driver is a module, because it's a generic config, we enable them. And there's also a new subdriver that's also enabled in the Gentoo config. And after these two are combined, then the setting for the Realtek driver is taken from the user config. It overrides the Gentoo default config, so that's not set. And this is an example of what can happen when new options are added in new kernel. They are taken from the Gentoo default, because the user config doesn't say anything about the data fab, because it didn't exist at the time. Then the default config says it will be built as a module. But what can happen is that in another kernel version we decide for the default Gentoo config that we don't want to enable debugging anymore, because it has some overhead and it was a mistake to enable it in the first place. So we disable it. But the problem is that the user config already contained the value that this will be enabled, and maybe the user didn't want it. He just agreed with the defaults at the time, and that means it would be kept enabled. And I think that is a problem. So yeah, the problem is how to distinguish which options the user really wanted and where he just agreed with the default, and we want to let him have the new default without any action on his side. So I think the solution is to pre-process the configuration from the user and to trim away the stuff that has the same value as the Gentoo config, and when the build, the image is run, then it will be combined again with the Gentoo default config, and the result should look the same as before the trimming, unless the default has changed meanwhile. So it would look like this. In the top left, there's the user config that has disabled the Realtek driver because the user doesn't have it. The Gentoo config has it as a module, and since it's the only option when the user and the default are differing, then this is the only line that goes to the trimmed user configuration. And when building is executed in image, then you get the Gentoo config to populate all those lines except the Realtek, which was set in the user config, so it overrides the default. And the result looks exactly the same as before the trim. And then if a default changes in the default config, so the debug is disabled, then it will be also disabled for the user, as I think it should be. But there might be maybe some users have some strong opinion about some of the configuration options and would be scared if they changed on an update. So they would like to make sure they don't change on the update. And for these options, the solution is easy. Just add these options back after the trimming. I'm not sure if anyone will actually want to do this, so if it's worth any tool support, but yeah, we will see. So how it looks like, really just after the trimming, which I've already shown, the user can add the debug option manually back to the trimmed config, and then it will override any future default changes. Another set of issues can occur due to the way the dependencies between config options are handled. So what happens is that if you disable some option that is a prerequisite for other options, then these other depending options won't appear at all in the resulting .config file. So that means the Gentoo configuration, the default one will then try to supply again the default options, and these will fail to be actually enabled because the prerequisite is disabled by the user. And we want to warn about some such dependency issues, but it would be bad if we were warning about them all the time, even for cases like this. So I think it will be best explained on an example. So on the top left, there's again this generic Gentoo config, and in the middle there's a user deciding that he doesn't want any USB storage at all, so he disables that. So the config USB storage is not set, but you can notice that the user config contains no mention about the debug or the Realtek, and that's because the real debug and Realtek have this depends on USB storage line, and how the kernel config works is that they won't be mentioned at all in the resulting configuration file. So when this kind of configuration file from the user is trimmed, it means only this USB storage line remains, because it's different from the default. And during the build, the resulting configuration would look like this. The USB storage will be disabled because the user wanted that. Then the Gentoo default will provide the options that were missing in the configuration file, and like the usual. But then there's a step in the build process called make old config, which will try to see if the configuration looks sane, if there are no conflicting options, or if some are missing. And it sees that you have enabled this debug and Realtek, but they depend on something that's disabled, so it will throw them away. So at this point we can compare if we failed to enable something that we were supposed to, and warn the user about this, because he might be missing something in the configuration. And in this case, when a user disables a whole file system, a whole subsystem, it's not really useful to warn him about each of the subdrivers of that file system. So a solution, I think, for this problem is to change the trimming process a bit. So if some option is missing in the user config, then it will be explicitly set as disabled in the trimmed user config as well, because if the user disabled the whole subsystem, it also means he disabled everything that depends on the file system effectively. So we can just state that explicitly. So in this case, when everything was explicitly disabled, then the Gentoo default wouldn't really override anything because everything was set by the user. And yeah, after the make old config, we realized that some options are gone because they were not satisfied. But since they were disabled, we don't have to warn or error out, because disabled and not present is really the same thing in the end. So that should solve this problem. So otherwise, how I think this will solve the issues I've mentioned on version bumps. So if new config option appears on a bump, then we can expect that the Gentoo default config will already know about this option, and it will be probably enabled. So what that means is you start building modules that you potentially don't want to, but it's not a big problem. Maybe if you do this for many versions, then the number of modules would start increasing, and then maybe you would have to, again, update the user config and disable them explicitly. It's a question if we could distinguish drivers from other options and let the user say disable all new drivers. That will remain to be seen. And yeah, it can still happen that the user has masked has disabled the whole subsystem, and as I've shown you on previous slide, all of the drivers that were under this subsystem would be also explicitly disabled, but a new driver can appear in a new version, and that wouldn't be again explicitly disabled, so that will become a warning that the user will probably have to do something about. The other options that the user didn't say anything about would be taken from the generic configuration, the default, so it shouldn't result in a bad system. So if the options disappear on a version bump and the user didn't care about them, that it's no problem. If it was something that the user explicitly enabled, then he should be probably warned about this, and then he could decide if he wants to try booting the new kernel or resolve this. There's no automatic solution for this, unfortunately. If options are renamed, maybe we could keep a list of what we know was renamed and do it automatically, but that's again hard to foresee until it's done. If some driver is completely replaced, like for the HP storage arrays, that often means that most of related configuration also changed, so that's still something that can be fixed automatically. So yeah, we can at least still give a warning to the user that the old driver has gone away and he can do something about it. Yeah, and if a new umbrella option appears on a bump, then it will be probably enabled in the Gentoo config, so it will not mask anything that the user has set. If some default changes on a bump, then it has to be a default change in the Gentoo config, because upstream defaults also change, but they will always be set in the Gentoo config. And if the user set something else, then he will still keep his own value. Yeah, the dependencies, as I said, are probably the biggest issue, and we can probably just warn about them or even error out if it's critical. And maybe we can do this in a phase before the emerge actually starts, so it doesn't break in the middle of the emerge, but yeah, it's hard to say more of it right now. Sometimes the user would want to update his config to resolve some of the troubles, warnings, or disable some drivers that have sneaked in. Meanwhile, we could provide a tool, but or extend make old config to do this. That will again be seen in the long term. There was a suggestion from one of my colleagues: why do this so complicated? Why not just have the emerge running, make local mod config automatically to strip away the modules that are not needed on the machine? And I don't think that's a solution, because it's not reliable enough. Yeah, some modules might be only loaded if you plug some USB device in, or you use some network protocol for the first time. And if you haven't done that within the system's uptime, then the local mod config will not see the modules loaded and will strip them away from the configuration. So you can lose drivers like this. And that also wouldn't allow all the other changes that the user might want to do. So I'm run out of time, so I will not discuss much about the step 3, which is to plug the eBuild dependencies into this. Yeah, once we know how to handle user configurations, it's easy to let eBuilds, like the NVIDIA drivers and so, also express their own configuration snippets that contain just the options they care about, and the whole process would just be similar, but process more than 2 files. And we can probably just re-implement a class that is now just issuing a warning about option being disabled when it should be enabled. So instead of issuing a warning, it will produce the required configuration snippet, and it should probably work fine. There might be conflicts, but then the conflicts between eBuilds wanting some kernel option disabled and other enabled, then these eBuilds should probably conflict on the depend level 2, so the portage shouldn't even allow you to install them if such conflict exists at all. Then there's a problem that the eBuilds would install some new configuration options, but they can't automatically trigger and rebuild or even a reboot of a kernel, so that cannot be fully automated. And yeah, sometimes the options might need to be present on the running kernel at build time already. That means the package wouldn't be able to compile at all until you do this stuff, and that means you have not got to the package in the source install phase yet, so you can't modify the config on the live file system. But then you can, probably just tell the user what he exactly needs to create a file and which content. So the plan is to go with all the steps as I've presented them in this order. So first, Gentoo kernel package with a default config. Maybe we can learn some experience from the Funtoo and Calculate Linux to help with that. Then there's the config manipulation that I've presented, and last the e-builds. Yeah, you've already seen this slide like this, so I won't repeat much. Just I've tried to check more specifically what we are looking for, who we are looking for in Prague, and I've counted 7 positions open, ranging from L3 support, QA. You can actually work on OpenSUSE, cloud or web. There's unfortunately no kernel position open right now, but they appear from time to time. And that's how I got hired as well, because Tomáš told me that they opened the position. And actually in 2 weeks we have a hack week. That means you can work on a project you want to, and I hope I can use this time to actually prototype the stuff I was just presenting. So that's also a nice benefit if you can do this on your work time once or twice a year. So thank you for your attention, and if there are any questions, you can ask.
Maybe instead of trying to manipulate the .config files, wouldn't it be better to augment the menu config to add options like I don't care about this, or if something you use, disable it, or which I guess for drivers, I don't want new drivers, but if the driver has options, I guess if a new option appears that depends, it's like a sub-option of this, I want to enable it. Mm-hmm. If, I don't know, I have a driver for Intel Wireless, and then it splits into, it has like sub-options for which wireless cards I want. So it's possible that there will be an option which actually disables the one I have. So I could say that I don't want new disk drivers because I have all my drivers. But if there's a new option inside that driver, I want it to be set. So instead of like messing with the config files directly, try to use the table system. Just give them more options than just enable, disable module. Give options like keep the default whatever it is, or if there's a new option, do this and that.
Yeah, that's possible. I've also thought about extending the cable system to do this, but I think internally it would be still a manipulation of .config files.
Yes, but you have to basically use the kconfig dependencies inside your tool instead of dealing with them on the level of the config. You have them as a tree, and you could have them basically as a hint instead of an issue.
Yeah, my point is that internally you would have to solve similar problems than that I've presented here, and I think it's maybe for Michal Marek, who works on kconfig, it will be simpler to do this right away in that environment, but at least for me, I think it will be simpler to prototype this outside of it, and then see how much of it can be upstreamable, because fundamentally it will be solving similar problems, just a bit somewhere else. And I don't think the procedures for trimming and combining are very difficult code-wise. It should be some simple scripts, at least in the beginning. But yeah, of course, trying to incorporate this upstream is an option after this is proven to work.
Yeah, I'm just thinking about basically the issue I see in this one is if there's a new option, do I want it or do I not want it? And what I think would be the best approach is to your user config files to have them not as an overlay over the normal .config files, but to have them like in extended format.
Mm-hmm.
So I can actually say that if a new option appears in this place, I want it. And if it appears in this place, I don't want it.
Oh. Yeah, that should be possible if we extend the number of NES module to. Yeah, that could be a way to get rid of some of the warnings before they appear. That if you say that I don't care about new drivers from this, I get. Yeah, that's a good idea. Thanks. Anyone else? Okay, if not, thank you and enjoy your lunch.